Senthil, you are on mute.
Good morning, everyone. Welcome to OCP Tech Week. Before we begin, I would like to express my sincere thanks to all the frontline workers and prayers to those who are affected with COVID-19. It is hard not to be connected in person, but I'm happy we could connect virtually. Before we diving into this lessons learned, we wanted to give you a quick overview on the applicability and deployment of SONiC in various use cases that we at Dell have deployed SONiC. There could be many other deployments. Happy to discuss with others on their journey and use case as well. On the left-hand side, what you see is a general applicability of an open source networking NOS, right? As you can see, the open source networking NOS has been penetrated in all the areas of use cases, right? Starting from data center to access to aggregation to core. And coming to open source networking NOS, which is SONiC, which is primarily focused on data center leaf and spine nodes, and currently they are venturing into the access and edge layer as well. On the right-hand side, what you see is the deployments where we have done SONiC, what kind of deployments we have done, right? Typically, wherever we have deployed as a class fabric network, as a pure layer 3 fabric, both starting at TAR or routing from host itself with BGP unnumbered and anycast, or a pure layer 2 fabric with a VLAN, MC lag, and a spanning tree based. And one of the most popular deployment what we have made is the fabric overlay network, which uses BGP, EVPN, VXLAN, running both BGP, eBGP in underlay and overlay. We have also deployed in a SONiC in a pure out-of-band management network as well. So these are the use cases currently we have deployed as SONiC. I wanted to take one single large deployment, enterprise deployment we made, and just walk through that. So currently this deployment is running across 8 data centers across the globe. We have close to 400 switches deployed in this DCs. All the tires, all the tires are running SONiC in their network, starting from leaf, spine, and the border leaf on the core switches. The typical class network running BGP, VPN fabric, as we told before, with MLAG and MC lag, anycast gateway as well. So each data center consists of 6 pods and 1 interconnect pod. And 1 pod consists of 20 racks per pod, and each rack has 3 leaves, a couple of data leaves, and 1 management leaf for the server management fabric. This is not the network out-of-band management fabric. The server management fabric is also part of the fabric here. And then we have totally 60 leaves and 4 spine and 2 border leaves per pod.
Thank you, Senthil. So now when we see what are all the features that are deployed across our customer deployments, we can see many legacy features like BGP, lag, etc. That are being deployed. Apart from it, we also have our enterprise offering, which adds additional features. For instance, we have a RPVST, and we have MC lag and DBB, etc. Next slide, please. So here are the advantages that we see across the board when we deployed across multiple customer deployments. So the first one is the flexibility. When we talk about the SONiC, the first thing that comes to our mind is the flexibility in which it provides during the deployment. I like to show a couple of examples here. In our first example, during the pilot testing, where the customer was testing some control plane ACL features, and the customer found an issue. The issue was narrowed down to a change in the CACL manager, and the community was quick to act and fix the specific issue. But in order to deploy the issue, instead of respanning an image, what we suggested to the customer was to do the fix via ZTP. We patched the CACL manager the daemon and then restarted the daemon as in the ZTP, which happens during the deployment time. So the customer was happy with it. And the second case is where during after the deployment, we found an issue where the IPv6 loopback addresses are the are advertised as a /64 instead of /128, which the customers was expecting. And then we figured out that the actual change needs to go in a specific template file, BGP template file. We suggested that modifying this template file and restarting the BGP daemon should fix the issue. And we were able to achieve the same using Ansible. So the legacy operating systems have some kind of hot patch and other capabilities which do trivial fixes, whereas when it comes to more complex fixes, the way to go was respawning an image and giving it to customer, and the customer had to go through an entire cycle of validating the other things when an image was given. But now with SONiC, the specific fixes can be patched and easily deployed without even need to go through an entire cycle. Next item, please. And extensible. The when this is also an added advantage, similar to when we say it's flexible to do bug fixes. It's also giving us an opportunity to extend our applications. So there are two customer requests which we got. We add the applications of NTP and syslog, but the customer wanted to have a specific use case where the customer wanted to advertise, want to send the NTP as well as syslog packets originating from the router to have a specific loopback address. To be exact, the customer wanted to have the loopback, the IP of the loopback interface. In order to do that, there is no support in the application as such. So what we thought was how to achieve it. With respect to the NTP, the change involved a simple modification in the NTP configuration file. So this we are able to patch using a ZTP script, and the functionality was achieved. The syslog involved a much more complex change. There was no support like in NTP where we modify the configuration files. We had to go, we have to make some IP table changes, and the catch here is we have to do it. We have to make sure that this has to be done across the reboot. So what we did is we wrote a one-shot task, and that would wait for the configurations to be played. And once it's done, it will pick the loopback IP and then add the IP table rule. In this way, we are able to extend a couple of applications which would have taken, say, at least a cycle, say a quarter or something, to go through the product development, validation, and the entire phase, and to be available to the customer. But we were able to achieve this kind of extensible behavior in a very short time, and the customer was very pleased in having such a capability. Yeah.
One of the biggest strengths of SONiC, it runs on a standard Linux distribution. Because of this, customers can take advantage of installing the third-party application they would like. In a couple of instances, we have seen a customer wanted to integrate LDAP, and they're able to do it as smoothly as possible to achieve that. So in the typical traditional use case, LDAP functionality itself took a long time to come in the traditional network operating systems. And one other such instance, customer really liked the Cumulus prescriptive topology manager. And then he really liked the way how it detects the link failures automatically. Cumulus has open source that. Customer was able to take that and package inside the LLDP SONiC container. He used just a Debian package. He just did the install inside the container. And then he was able to verify the topology with that. In yet another case with a service provider, they want to reduce their one service which is used for the infrastructure. So they wanted to install Metal as a service from Canonical in the SONiC itself, so that they can provide the necessary image and the DHCP services for the server infrastructure. So customer was able to install Metal as a service in that one. And then customers, these are third-party applications, and customers are enabling their own custom applications as well. So we have seen customers, couple of customers have written their own orchestration agent and then their own ping mesh agent in order to validate, monitor their network as well as orchestrate their network. And we have seen customers also use the native Linux third-party applications as well, like Monet, which is already packaged in SONiC, but the customer is using for monitoring every file changes in the system. And they use Snmp to check every command executed in the system. So it brings, the SONiC openness brings a real strength and power to SONiC as well as to the customers. SONiC users loves the manageability aspect of SONiC. SONiC provides various interfaces from Ansible to industry standard CLI to SNMP, REST, and GNMI. So what customers love about it, it can cater to sophisticated enterprise customers to a very simple enterprise customers as well. So simple enterprise customers, they're happy with their industry standard CLI, where they're able to quickly migrate from existing traditional OS to a SONiC NOS. And then a sophisticated enterprise customers, they took the OpenAPI spec from the REST interface, and they're able to generate an SDK with their language as choice, and then they're able to integrate with their orchestration system. And one of the key things about SONiC is adaptability and the power of choices SONiC provides. As we talked about initially about the mass installation, so in a service provider network, how it can adapt itself, there is a hardware choice. During this testing times, there was a significant delay in hardware, and customers were able to significantly reduce their hardware lead times and the cost, because there are various choices available for them in the market in order to deploy SONiC. And currently there are works going in SONiC to deploy them in the NICs and servers as well. Now we have seen all the advantages of SONiC brought to the table on a production journey. Let's look at the challenges we faced during deployment. It doesn't mean that it does not come with the challenges. We faced a lot of issues, but we are at a point right now, after a year and a half of deployment, we are at a point right now we can clearly say that it's going well. So I would like to talk about a couple of challenges we faced during the deployment of SONiC. The first one is the feature interoperability. SONiC being new to the enterprise market, currently it was mainly deployed in the cloud networks, right, like Microsoft, Alibaba, LinkedIn kind of thing. But when it came to enterprise network where we started deploying, we started seeing some interoperability issues. The first issue I would like to talk about is one of the issues, interop with the other external features. One such example is TACACS. TACACS by default uses authentication first and then authorize, but as per the spec that is optional, you can directly try to authorize as well. But SONiC being a Linux-based TACACS client, it sends an authentication with a fake password just to protect, to validate, but to know that the user is valid or not. Because of that, we are not able to interrupt with the TACACS. This is one of the major vendor providing the IAM service, and all other network operating system traditional work were able to interrupt. So the vendor has taken an enhancement, and we are trying to fix that in SONiC as well. You could have seen there is another talk coming on that, especially enhancing that, and then there is already a pull request and HLD available in the community to address that. And the other issue we faced with the RPVST interop with a leading vendor as well, right? And then we have to fix it, and then we have to move forward with that. The next one I want to talk about is the interoperability within the SONiC itself. So we have developed a feature management VRF, but the interoperability between the IP services features inside the SONiC along with the management VRF was not, didn't work as we expected. The management VRF was working fine, but the services running on top of like syslog, NTP, they need some tune-up in order to work with management VRF. And then the capability of additional Linux Ansible, right? So those were getting lost. So if you take Ansible and then people were before management VRF, they're able to deploy all their existing standard Ansible playbook. Once we moved into management VRF, they are not able to execute because every command in Linux needs a CGXA command in order to prepend the prepend with in order to execute the command successfully. So the next one in the interoperability itself, we talked about external third-party interop. We talked about interoperability between the same feature set within SONiC, and then interoperability with the existing tool chain with the customer. So this is SONiC has a lot of logs. The logs grow pretty quickly over the period of time. So they had a customer already had an infrastructure to collect and save the logs periodically and everything, right? So initially, when we first deployed, when we did the pilot, the logs was exhausted just within 2 days. The SONiC logs can go up to 2 gig of file size currently, right? So all those enhancement has gone in. So there is a syslog cleanup here, and you can now state in the tech support how much time you want to get it and how big size of you want to get it out, right? So all those things has been addressed right now, but these are the challenges we faced during those times. With containers-based architecture, SONiC comes with a lot of advantage, and but it also brings us a lot of challenges with respect to maintaining them. As you're aware, the couple of challenges we faced with respect to security as well as with configuration. The customers were not able to use their existing security or vulnerability scanning tools because the existing tools does not cater to their need of container scanning. So they were just doing the host-based scanning. Now with SONiC coming as a container, so they need to either enhance their tools or enable the additional features in their tools or buy a new set of tools for the security and vulnerability scanning. And then containers in SONiC, they run in a privileged mode. Example is a management container itself, which runs in a privileged escalation mode, where they have full access to the host operating system, which violates the container boundary. So security was a little bit of a concern where we went to the banking and other sector when we deployed in those kind of areas. So we have to take additional measures in order to prevent that. And with respect to configurations, container configuration itself, because the third-party containers, we are not able to persist the container image during upgrade. And then all the other stuff which we need to do in the container, right? They have installed the certificates in the host-based system. Now they have to do it in all their third-party containers as well for in order to achieve that. And for the DNS and everything, right? All those IP ACL rules, whatever they have done with respect to host systems, now they have to repeat those things in the containers as well. So that led into a couple of more complicated stuff. And then after image upgrades and installation, they have to redo their entire work on the containers.
So with respect to the config management, there are quite few challenges that we faced. One of the major concerns that raised by the customers is the lack of unified configuration. So SONiC, as such, we know the most of the configurations can be done in the can be part of config db.json. However, there are instances where the configuration needs to be part of a different configuration file. I'll give you two instances. One is whenever the user wanted to have an advanced BGP or a fine-tuned BGP configuration, and those configurations cannot be part of the config db.json. The user has to go through a split mode where the user will configure the BGP specific configuration in the frr.conf. The other instance is where the user has to specify the community string in the SNMP for the SNMP, and this is done using the snmp.yaml file. So the request from the customer was to have a mechanism in which all these configurations can be a part of a the single place, and the customer expects a single source of truth. So to solve this for BGP, there is a work in progress where for every possible control, there is a corresponding config db.json specific entry match created, and the community is working on it. So again, the request is in even for the future configurations, whenever specific modules are added, it is best practice to make sure those can also be configured via the config db.json. The second kind of request is having a the is to have a better configuration validation. So as we know, the config db.json, the configuration schema is it can be very can be very elaborate, and the challenge we find is the specific configuration schema might change across different releases. There are two instances where we faced issues. In one of the instances where the user wanted to enable rpvst, the user had specified the configuration at the global level and expected it to work, but the rpvst didn't work. Then we recommended the customer to enable at even at the local port level. So this is the problem that the customer face with not knowing the underlying schema. And the second instance is where the customer had mistakenly specified the e0 as a part of the port section in the config db.json. So what this resulted in is, after the configuration was loaded, the system didn't come up, the ports were all down, and the customer wanted to figure out what the issue is, and we narrowed it down to this specific issue. So the uh, the the challenge is it's very difficult for user to know the underlying schema, and with the schema not being documented across different releases and it might change. We are recommending the your customers to go with the management framework, which abstracts the underlying schema and provides a way for the user to configure without having to bother about the underlying configuration, and avoid any errors. And the third instance is there are certain configurations can be loaded via the config load mechanism. So but what we see is there is no uniformity in the behavior. There are few applications which do not work as expected when we do a config load. Most of the applications, when we do a config load, will load the incremental configurations, and then those get applied. One specific instance I would like to show here is the customer wanted to add the number of routes to the forced management routes. That is part of the uh, management port configuration present in the config db.json. The customer added the incremental routes and did a config load, and the customer didn't see the changes taking effect. Then when he reached out to us, we recommended the customer to do restart of the interface service. The reason is the interface service is not actively listening to the configuration changes. Uh, so that whenever we make some changes in that service with respect to the configurations, that service has to be restarted, and so that it picks the latest initial configuration. So we've found few instances where this happens, and we have modified the application to actively listen to it, and we are also planning to upstream those changes. And our recommendation here is any application that's being currently developed should be listening actively to the configuration, and we should have a default behavior across the board. Next item, please. Okay. The next comes the monitoring, where we faced a few challenges. As Sendil was pointing out, syslog is one of the areas. The syslog, the number of syslogs emitted are huge, and some cleanup needs to be done. And as Sendil was pointing, there is some cleanup changes that is planning to be raised in the community. The other issue is the format of the syslog itself. So there is no uniform format that is being found currently. And the syslog, some of the syslog contain certain internal API names, parameters, etc. So these are all need to be formatted, and we are soon having a roadmap item to work on those syslog formatting. The next problem with respect to syslog is many crucial events are not logged by default. For instance, the customer was expecting the BGP neighbor changes to be logged, but it was not logged. Then we suggested the customer to enable the log neighbor changes in the FRR to enable it. So we should also categorize the important syslogs, and those need to be enabled by default. The second monitoring issue is the limited SNMP capability. SONiC, as we know, is progressing towards advanced capabilities like telemetry, GNMI telemetry. But the problem we face is the most of the customer deployments are not ready yet to go to a place where they can consume the telemetry data. They don't have the infrastructure to process the telemetry data and perform monitoring based on it. So most of the customers rely on SNMP, and that's where we face challenges. There has been some amount of support in the SONiC with respect to SNMP, but the requests from the customers are elaborate, and this needs to be enhanced in our opinion. So as a part of doing this, there is a SNMP support for BGP that is being worked on, and it will be raised shortly in the community. And we also have a roadmap to enhance the SNMP capability in SONiC. The third important aspect is the lack of threshold for platform monitoring. As we know, there are a lot of platform monitoring requirements from the customers, like a CPU threshold, memory threshold, or say the temperature sensors, or etc. So SONiC as such doesn't have an inbuilt application today to perform these monitoring and raise syslogs, for instance. Most of the customers have an infrastructure where they have an external application perform this monitoring using SNMP, and then take action. However, when the enterprise, when the few customers don't have this capability and expect it to be done by the NOS itself, that's where the challenge comes. So in order to do that, the current community release is working on a system monitoring feature, which I think will be helpful for those customers who rely completely on the NOS to give the information. So next. So the next thing I would like to talk about is the VS image. So most of our customers are requesting support for the VS image in order to do the pre-deployment kind of validation. So they wanted to set up a virtual network where they could validate the VS image with their configurations and then before the deployment itself. But there are quite few challenges there. The first major challenge we face is not all the operations are supported. For instance, when the customer has ACL rules in their configurations, they don't translate exactly to say IP tables in the VS image. So when the customer has an ACL rule, we do not find the corresponding functionality working as expected in the hardware. This is one instance. So these are all the places where we need to enhance and provide a behavior as close to the hardware. So it will be helpful in the pre-deployment. The other thing is the image size and the memory consumption. So as I said, the customer's pre-deployment environment will host many number of VMs, and this will consume a lot of memory. But the current SONiC image size is a little huge for them, and this poses constraints on the number of images that could be deployed and the topology that could be constrained. So it would be good if we can work on reducing the image size and the memory consumption of the VS image, so that it would be helpful to have it could enable the customers to support a bigger topology in their pre-production. And next slide, please. Okay. So now we talked about all the challenges that we face. What actions are we planning to take? The first one, as I said earlier, the syslog cleanup PR is on the works, and this will be upstreamed into the community. And syslog formatting discussion is already been started, and we are expecting some works to happen in this area soon. The other thing is the third-party application management and the container management. As we know, there is also a talk that's planned after this, and the community is actively working on it. And we are also giving our feedbacks based on our customer experience in deploying the third-party applications. And with respect to monitoring, there has been ongoing works with the GNMI enhancements in the community. So there is a GNMI Telegraph plugin for SONiC. It's created by Dell. The pull request is in the slide deck, and this is soon expected to be merged. And as I said earlier, the SNMP roadmap has been planned out. And the first one to go in is the BGP MIP PR, which is going to be raised soon. And with respect to the system monitoring, there is a feature that is in progress in the community, and which will be helpful for the customers.
What we ask the community is join the SONiC community. It's a very vibrant community. You can join a mailing list of Slack, start participating and voice your opinions, right? Take SONiC for a test drive. SONiC OS comes with a virtual environment. It's easy for you to spin up a SONiC VM easily, and you can start deploying in a small non-production and controlled minimum disruptive environment. Right? I'm pretty sure that SONiC will lend itself very well for your use cases. I apologize. I think we consumed most of our time today. We'll be available in the chat window in the FN platform as well. I'll leave it for any questions. Thanks for that.